right, so now we're still going into math, and we are in the quadratic equation section. So given this problem, the voltage across a capacitor in an RC circuit is modeled by the equation. So, we have our basic RC circuit. We have our, let's say we have a low pass filter here, right? We have this out, and it's modeled by this equation. It's modeled by this equation, V of t, or V out of t, is equal to t squared minus 6t plus 5. Okay, so when it's saying V of t is in volts and t is in seconds, find the time at which voltage is 0, time or times. Okay, so how do we find out when voltage is 0? Well, that means we need to set voltage equal to 0, right? So we have 0 is equal to t squared minus 6t plus 5. And what do we notice? This is just a basic quadratic equation. Okay, so again, we could factor, or we could use the quadratic formula. Doing this problem, we could factor. We could do, what, minus 5 minus 1? Okay, so t squared minus t minus 5t plus 5, t minus 1 minus 5, t minus 1. You get t minus 5 and t minus 1. Okay, perfect. And we have our equation, our set values. Yeah, okay, so t, 1 and 5. And that solves for part A, or part 1. Part 2, it says determine the minimum voltage and the time it occurs. Okay, so remember, we're in the quadratic formula section. We are not in the derivative section. You could very easily solve this by taking the derivative and finding when the derivative is 0. So, we could do 2t minus 6 is equal to 0, so t is equal to 3. And then we would, plug in 3 into the original equation. 9 minus 18 plus 5, so minus 9 plus 5 is equal to minus 4. So we have a minimum at 3 minus 4, and this is in seconds, and this one is in volts. So at 3 seconds, our capacitor charges and has negative 4 volts. So it's, reverse polarity. You could do it this way. Another way you could do this is you could say the vertex of our equation, and maybe I shouldn't do this, but they do this sometimes in the answers or in the solutions to exam prep. They say the vertex is equal to b over 2a, which is 6 over 2 times 1 is 3. I'm not entirely sure why it's positive 3. It should be negative 3 then, but it is positive 3. At least that's what it's giving me here. And so then you would plug it in. This is your vertex, your x value of the vertex, so it would be something like this. And you can do this because it's a quadratic formula. You know there's only one vertex. There are 2 zeros and 1 vertex. That's all you have to know. But yeah, that's how you would do this. You then plug this number back into the original equation and get your y value. So that's the minimum voltage and the time that it occurs. Right, so hopefully this was helpful. If you have any questions, of course, comment it, and I should get back to y'all as soon as possible.